Multiplying fractions. Basically, you just multiply the numerators and then multiply the denominators. An important fact that we're going to use when multiplying fractions is that anytime the numerator is equal to the denominator, that fraction is equal to 1. And 1 times any number is that same number. And we're going to use this to reduce our answer. Let's look at an example. So you want to reduce before you multiply, which means if there's a fraction that's equal to 1 in your multiplication statement, that will reduce. So looking here, 7 over 7 is equal to 1, and 2 over 2 are equal to 1. And it doesn't matter if they're right next to each other, because remember that multiplication is commutative. Once you've checked that every possible factor that occurs in the numerator and the denominator are canceled, you get your answer. So you want to reduce before you multiply. Let's do another example. So if you're multiplying 21 over 15 times 25 over 45, you want to break them down first. 21 is 3 times 7. 15 is 3 times 5. 25 is 5 times 5. 45, I could do 15 times 3 or 5 times 9. And I'm looking at this 5 here, so I think I'll do the 5 times 9. So 3 over 3 is equal to 1. 5 over 5 is equal to 1. 5 over 5 is equal to 1. So the answer is 7 over 9. Let's do another. Let's multiply 70 over 27 times 45 over 30. And if you want, you can hit pause and work it out and then check the answer. All right, so right away, I'm going to recall that 70 is 7 times 10, and 30 is 3 times 10. So I can reduce 10 over 10 is equal to 1. 7 is a prime number, so we're done there. 27 is 3 times 9. 45, again, we could go 3 times 15 or 5 times 9. I'm looking at this 9 here, so I think I'll go with 5 times 9. It's okay if you start differently though, as long as you keep going and keep reducing, you'll get the correct answer. So 9 over 9 is equal to 1. And you might be eyeballing these 3's, thinking those cancel, but because they're both in the denominator, they do not cancel. We get 7 times 5 over 3 times 3, which is 9. All right, let's do another example. This one you'll use your divisibility rules that we talked about in the last section. So 95 is not in your times tables, but because it ends with a 5, you know that 5 goes into it. So you divide by 5, and you get 5 times 19. 38 is an even number, so 2 goes into it. And we get 2 times 19. 34 is an even number, so 2 goes into it. 85 ends with a 5, so you divide by 5. 19 over 19 is equal to 1. 17 over 17 is equal to 1. 2 over 2 is equal to 1. And 5 over 5 is equal to 1. So what we have here is 1 times 1 times 1 times 1, which is equal to 1. So if everything cancels, your fraction is equal to 1. All right, for the next problem, let's recall that 5 divided by 1 is equal to 5. And you can write 5 divided by 1 as a fraction by putting the 1 in the denominator. So we can use this idea to write a whole number as a fraction when you're multiplying a whole number times a fraction. So you just take your whole number and write it as a fraction. And then just like before, we reduce before we multiply. So I would break down that 6, but because I've noticed that it goes into 48, I'm not going to bother, because 6 over 6 is equal to 1. 1 times 8 is equal to 8. So we just get 5 over 8. All right, the next example, you notice that I've written it down twice because I wanted to talk about that fact that you can break it down however you like. As long as you keep going, you'll end up with the correct answer. So 36, I could either do 6 times 6 or 4 times 9. 15 is 5 times 3. 72 is 8 times 9. So let's start it the other way here. 36 is 4 times 9. So if I start with 6 times 6, I can reduce 5 over 5. And then you just check and say, am I done? And the answer is no. I can keep breaking things down. So I'm going to circle everything that's left just to make sure I don't leave anybody on the side of the road. What do I have left? 2 is a prime. 6 is 2 times 3. 6 is 2 times 3. 1 times 3 is 3. 8 is 2 times 4. 9 is 3 times 3. 2 over 2 equals 1. 3 over 3 equals 1. 3 over 3 equals 1. What do I have left? I'll keep breaking this down. So 2 times 2 over 2 times 2 times 3. 2 over 2 equals 1. 2 over 2 equals 1. You can imagine there's a times 1 here to remind you that if everything cancels in the numerator, you still have a 1 in the numerator. All right, what if we started this way? 5 over 5 equals 1. 9 over 9 equals 1. I'm going to circle what's left, just so I don't forget. And then let's break it down. I have 2 times 4, which is 2 times 2 times 2. 8 is 2 times 4. 2 over 2 equals 1. And then I can break down this 4. Over 2 equals 1. So it doesn't matter how you start, as long as you keep reducing, you'll eventually get the correct answer.